Alright folks, so for this video, I'm going to be using three basic variable types: integers, longs, and doubles, okay? So the first method to achieve converting from a number to a string is to essentially use the toString function, okay? So this toString function exists from C++11 and forward implementations of the C++ compiler, okay? So here I just define these variables, so an integer, a long, and a double with multiple decimal points. Then I have a string for every single variable type, and I use toString to get the respective result, and I output the results just for us to see afterwards. Okay. Now the second method, and the reason you're probably watching this video, is to use your own functions to do that. Okay. So I define my toString, which can take I overload it to take three different parameters. Essentially, for the double variable type, I use two variables. So the second variable is the accuracy that I need to achieve from my toString function. So if I say 15, I need 15 decimal points. That's what I mean, okay? And then I just simply output the results just for us to cross-check my toString with toString, okay? So let's look at the implementation. So for the integer variable type, what I'm just gonna be using is the definition for the long variable type. So I essentially just cast x to long here, and since I have defined this before, I can reuse this for my integer types, okay? And the result will be the same, since it's just a string, okay? Now, for the long variable type, I have an empty string, which I call solution, and then I just do this simple while loop, okay? As long as my number is greater than 0, I modulo that number by 10 to get the last digit. Then I divide by 10 so that I remove this digit from my number, okay? And then I append to solution this character. So I append it in the beginning. So since we go from right to left, I will be following that order on my string as well. So I will be appending on the left side of my string every time. And then I return the string. So why does this while loop work? We will be looking at an example here, and we will be running this same loop, okay? So let's say we have 1, 2, 3, 4 to be x, okay? So x equals to 1, 2, 3, 4, okay? So if I modulo by 10, so let me just type 10 here. Alrighty, so 10. If I modulo by 10, what I achieve is to isolate the last digit, okay? Because if you do 1, 2, 3, 4 module 10, so 1234 module 10, what you will be getting is the last digit, okay? So this is my result from moduling. So I get this into last, so let's define last here as well. So last equals, and in this time, in this first modulo step, it will equal to 4, okay? So I have isolated the last digit. Now by dividing with 10, I will remove this digit essentially, okay? So 1234 divided by 10, when we have integer division, that's what we're using here, it's integer division. What we're left with is 123, okay? So now that I have the last digit removed from my number, I can also go ahead and append it into my solution. So let's define solution here. Okay, equals 2. And I append this digit in the beginning of my string. So the string initially is empty. Okay, so this is, let's say that this is an empty string, okay? So I get 4 and I append it in the beginning of my string. Okay, so here on the left side of my string, okay? So 4 is appended here. Now we can just go ahead and remove this. So this is my string now, it's just 4, okay? Now moving onwards to the next iteration of the loop. So x is still greater than 0. So I again modulo by 10. So I get the last digit which is 3. Then I divide by 10. By the way, I'm going to save it in my variable last. I divide by 10, so this digit is removed from x. And then I append this to the left side of my string again. Okay, so 3. Then I do the same, since x is not 0. I modulo by 10, so I isolate the last digit, and I save this to last, okay? And then I divide by 10, so this digit is removed. So I put this in the beginning again, and then I do the same with the last digit. So x is still greater than 0, so x modulo 10 equals to 1. X divided by 10 equals to 0 essentially, okay? So x now equals to 0. And the last gets value of number 1, okay? Which is the digit that we got with the modulo operation. So we get this digit and we append it again on the left side of my string. So my string now equals to 1, 2, 3, 4. So I will be returning a string here. And that's pretty much it for the string conversion of integer numbers essentially, that only have integer part. So let's move onwards to numbers that have decimal points as well, okay? So double x. Here I have defined the accuracy as I have mentioned before. And what I do initially is to get the left part of the number. So let's visualize this. So we have 1, 2, 3, 4, okay? So this is our double, okay? And I cast this x, okay? So this is x essentially. I cast this to a long and I put this into a variable called left. So let's define a variable called left, okay? And by casting x to a long, I essentially only get the integer part. So left now will equal to 12. Okay? And I use this long variable now, okay? And I use the my2string implementation for the long variable types, and I save the result into left s, okay? So let's call it left s, okay? So the result will be 12, okay? That's what we will save in left s essentially. And then I append a dot in the end of the string, okay? And now I remove the integer part from x, okay? And I save this to a variable, a double variable called right, okay? So right here equals to x minus 12. So it will equal to 0.34. Let me just type this, since my mouse doesn't seem to work. So 0.34, okay? That's what is left after we remove the integer part from x, okay? Now I go to this loop, which will iterate accuracy times essentially. So if we want 15, it will run 15 times. I multiply right by 10, so right will become 3.4, okay, when I multiply by 10. I get a digit, which is the integer part of right, okay, so this is the casting to long again to get the integer part of right. So let's define d here equals 2. This time it will be equal to 3, okay, because if I cast right to long, I only get the integer part, okay. Then I remove from right this integer part, so right will now equal to 0.4 essentially, 0.4, okay, because I remove this integer part. And then I go to the string and I append this character at the end this time. By saying plus equals, I is essentially appending this character to the end of the string. And this character is again the integer value for that digit plus the ASCII value for the 0 character, okay? And I repeat this again. So I'm going to be doing this 15 times if I say that this is 15, okay? Again, I multiply by 10. So now right will equal to 4.0.0, okay? I get the integer part by casting right to long, okay? And this is saved to the d variable, okay? Then I remove d from right here, okay? So right will now become 0.0. Actually, it's only zeros, yeah. 0. All the zeros at the end, okay? And then I append again this digit that I have in d at the end of my string. So initially I appended 3 here, okay? And now I append 4, okay? And if I keep repeating this, now that I have only zeros, essentially what I will be appending is zeros all the time, okay? 15 times, so you will end up with 15 decimal points here, okay? Okay, that's pretty much it. So this is the visual explanation for the double variable type implementation as well. So that's pretty much for the implementations. So let's go ahead and run this code to get the results that I output here. Let's see what happens. So as you can see from the results, for the integer numbers, we essentially get the same results from toString and from my toString. But for the double variable type, so if I run toString, it will give me 6 decimal points in this case, okay? But if I run my version of toString for double variables, since I mentioned here that I want 15 decimal points, what I get is 15 decimal points, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, okay? So that's 15 decimal points. But you may notice that there is some inaccuracy. So after these numbers here, so I have 1, 2, 3, 4, and then I have 1 again, okay? So this should be 1 here. But what I print is a 0, and then it is followed by 9, okay? So these inaccuracies are possible to happen because of the fact that when I multiply by 10, or when this number is saved into the double variable, we might have some accuracy being lost, as we know, okay? Another thing to notice is that in my implementation here for the double type variables, I cast x to long. So that assumes that x is small enough to actually, so that its integer part can actually fit into a long type variable. If you have an insanely large number, this will not work. You will have errors. So let's go ahead and break this just to show you that it will have errors. So let's use just a lot of numbers essentially. This will not even compile actually. So if I get this here and I multiply it by itself, so it's 18 plus 18 zeros, so this is 10 to the power of 18. So 18 plus 18, that's 36. So it's 10 to the power of 36. So that will not fit in a long variable type, okay? So let's just compile this. Actually, the multiplication might not even happen. Yeah, you get an integer overflow here, you see? So the implementation assumes again that you can actually have your number being able to fit into a long variable, okay? And that's pretty much it for the video, guys. If that was helpful for you, please leave it a like, it helps a ton, and I will see you in the next one. Goodbye.